Welcome to my YouTube channel. Today I will be discussing how to repurpose photoelectric garage door sensors for a security system with schematic details followed by a demo. When I decided to add photoelectric sensors to the security system, I was unsettled by the price of most through-beam photoelectric sensors. I then discovered the photoelectric safety sensors for garage doors were also through-beam and the best value. The two most popular and readily available safety sensors are for Genie and Chamberlain, which the latter is also used by LiftMaster and Craftsman. The Chamberlain sensors are more difficult to repurpose since the voltage briefly drops about every 5 milliseconds. Conversely, the Genie sensors not only came with the brackets. After adding a 2200 microfarad capacitor in the circuit, the signal is steady low when transmitting and receiving, and then steady high when the beam is broken. Regarding the schematic for the Genie sensor, of which this circuit can be wired into most security systems containing a normally closed contact, such as the terminals used for motion detectors, in this schematic there is a 4-pin header and 2-pin header. While the 2-pin header is labeled as 5 volts, the MOSFET can also handle 12 volts on this header if the security system you are using is for only 12-volt switching devices. The only reason the 2-pin header is labeled as 5 volts is because I am wiring this into the custom security system I designed. The only difference in this security circuit compared to the PCB-ready circuit presented in my security circuit with auto reset video is I added another LED and a critical test button for if and when the power supply and battery backup both fail. And then when powering back up, if the alarm fails to initialize, a momentary push of the test button will reset the security circuit back to normal operation. Regarding the 4-pin header, pins 1 and 2 are for the 12-volt input, and pins 3 and 4 are for the Genie sensors. The LED in the circuit is always on when the board is powered up. Below the LED is a voltage divider with a 2K resistor and 10K resistor, equaling 10 volts at the LM358 comparator. When using a 2200 microfarad capacitor to smooth the signal out to within a millivolt, and a 47 ohm resistor, when the Genie sensor beam is broken, the voltage will jump up above 10 volts, and then the comparator will open the MOSFET, causing an opening condition in the security circuit to activate the alarm. Regarding the demo, there are two things to observe after I break the Genie sensor beam. The voltage jump up on the voltmeter, and the blue and red light on the security circuit breadboard turn on, of which represents the alarm. See how the voltage jumped up from just below 10 volts to just above 11 volts? See how the voltage dropped back down below 10 volts? After a brief delay, the blue and red LEDs will turn off, representing the security circuit auto resetting. If you like this video, or just learned something in this video, please click like on the YouTube page below this video. Thank you.